Keep talking.
Remember to look out for where all of these screws are being pulled.
As I talk, it's clear.
The screws might be hard a little bit to lose, but try all you can to make sure you lose them.
So whether some of the screws the same size.
That is why the screwdriver you have, which is a magnetic screwdriver, now I am removing them one by one and I'm keeping them safe so that whenever I need them, I can go back to them at will. Now I have removed every inch that holds the ground floor to the body. Now I'm removing this part that holds the ground floor to the body. So in case you try to remove it and it is not opening, definitely there are some screws that are being unloosed, which we need to go back and check if you lose all of these screws. Because if you didn't lose any, if you mistakenly leave one of these screws unloosed, you will not be able to remove it as I'm removing it now. Wow. So this is our autonomous robot. It has been programmed and it has already been coded. But we are dismantling it so that you can see what exactly a robot looks like. After this class, there is a video section that will be passed across to everybody. You might just hold on and be watching this video, but there is a detailed video that will be sent on how to dismantle this to you on your various devices so that you can try your hand on them at home. Now, as Mr. Larry said yesterday, the components of a robot are in different form. Now, we have a motor here. We have a rotating spring, we have a rotating carcass, we have the tires, and we have the chip where it is being coded on. Now this is the tire. These are the tires. As Mr. Ellery has shown you yesterday, these are the tires, and this is the moving spring. This is the moving spring, and this is the moving carcass. When we lose it, the motor is inside. The bridge motor controller is inside. And this is the switch. The switch is here, where you can put it on and put it off. It is being programmed to the motor controller inside, and as well the battery cage, so that whenever you source it with the power, it moves, and you put it on here, it moves. That is how it is being programmed. Now we are removing all of these things one after the other. I want you to be very careful with all of this, even with all of the screws, so that you don't misplace them. The screws are different from each other. This one I am removing now is different from the one that holds the ground floor to the body. So you have to separate them amicably so that you don't get them mixed up together. We have three screws. We have three screws holding the moving carcass to the body, which I have removed. Now this spring is responsible for the movement of the 360. Now when you put it on, you will see that it rotates 360. It moves at 360 degrees to the right and to the left. This spring is responsible for that. So I'm losing out the spring as well. Like I said, you have to be very careful with this. Sometimes they might be hard to lose. Now I'm removing the moving spring. Look at it very well. Now, this spring is 2, but you have to fix it in each order. It won't work like this, or rather, it will work and it won't work perfectly as you want, putting them on each other. But you have to fix them inside of each other before placing it on the carcass. Which all of this will...
Hello everyone. There is a very clear video that will be shared after this practical section that you can watch and practice on your own. So don't worry if you really can't see anything right now.
So now I am removing the carcass. This is the moving carcass. Why it is called the moving carcass is because of the motion here. This carcass is actually responsible for the movement of this humanoid up here. It is being connected to this rotating spring that every 360 degree this humanoid stands. This humanoid stands and clip back. So this is responsible for that. Now, this is a very tedious place where you take a very good cognizance of, because any mistake from here, I think you will have to start all over again. Now let me explain this to you before we go on. This is the chip where it is being coded on. This chip is connected to the humanoid. It is connected to the switch. It is connected to the rotating motor, to the bridge motor controller, and it is as well sourced. It is as well powered from the battery cage here. So it is on this chip. It is on this chip that the programming of the 360 movement, the programming of the going front and backward, the programming of the humanoid being standing up are being set on. So this chip is let me say the back end power for all of these carcass. So without this chip, all of these things won't be working perfectly. Now let's take, for example, without the microbit being coded on, even if you have a microbit chip with you, even if you have a microbit gadget with you, it will not work. If you have a microbit gadget and you did not code it the same way we coded it in the last class, you will not see anything on it. It will not give you any result. That is the same thing applicable to this. If this chip has not been coded that it should move 360, stand the humanoid, go front and backward, then it will not do anything. It will be a total waste of the whole body. But because it is an autonomous robot, it has been coded on. It has already been programmed. Now, all of these wires are very sensitive. They are very, very sensitive. We call them male to female wires. We call these wires male to female wires. So they are the one transferring the source and the information from the chip to every part of the carcass. Now for the motor, for the bridge motor controller, it is from this chip that it gets its command. And it gets its command through these male to female wires. The humanoid transforms to stand and go back because it gets its directive from this chip. It gets its directive through these male and female wires. Now I think you should know why and how much these wires are very, very important to this. Now this switch too, this on and off switch, has been programmed on this chip, but it gets its control from this wire. The program is on the chip, but it is being transferred to the panel through the wire. It is like, let me say, adrenaline in human body. Adrenaline is an hormone for emergency. Now, if you cut your hand with a blade, it translates to your brain immediately that you have injured your hand. That the next thing to do is to find a first aid kit or call your mom or dad. Exactly the same way with this. This chip here is just like an adrenaline being programmed to settle all issues that involve this robot. So immediately it transfers all the information required to the bridge motor controller. That starts its work. Immediately it transfers the one for the humanoid to it. It starts its work. Immediately it transfers the one for the switch to it. They start their work. And the speaker too is not left out. The speaker too works as per the configuration of how it should work on the chip. I hope you are getting it. Now this chip can be coded for a preliminary, for an elementary class. That is why I take microbit first. So that is a typical example of how you can build in blocks to make code. Advanced programming languages are being used to do this, like Python, CSS, JavaScript, C++, C# are being used to program this, which if we start that now, you will not be able to get most of it. That is why the microbit is just a starter kit for you and a scratch. Now let's continue. Now let's continue to decouple it. Don't forget I said every screw you remove from this carcass must be well placed, must be well kept, so that you know exact points and exact place you will remove them from. And like I told you, be very careful of the wires, the male to female wires. Please arrange these screws very well, as they are very, very important when you are coupling the robot back. Now Please be mindful of everywhere I remove the screws from.
That is it.
Now this thing, you can try it as I'm still removing the screws. I'm still removing all of the screws now. Just hold on. Follow suit, please. Yes, we'll send it. Don't worry, we'll send it to the Telegram group, or we'll send it to the chat too. Okay, now for this screw.
Don't mute yourself. No, talk about that screw. If you come on the box without the screw. If you come on the box without that screw.
So for this screw, you might actually leave it because there is a spring under it. Do you understand? So you can remove this box. You can remove this hinge here without removing this, without losing out this screw. Do you understand? It has a spring under. So you can remove this without removing the screw. Now, going forward. Yes, good. Now we have the inside. Now we have the inside of our robot. Now this is it. I hope everybody is seeing this. Please keep all of these things very well. Keep all of these things very well. What do you think of this thing? Now, if you are hearing me, you see all of these moving gears. These whitish gears you are seeing, they are called moving gears. It is just like a normal car. Don't worry, you will get the video. Just hold on. You'll get the clear video of this. Now, just like a moving car, just like a normal car, there's always an engine, a gear, a propeller, a tire, and all of those components. Do you understand? Now this is the moving gear for this robot. Without all of these components here, this thing will not move, even when it is being coded on. Do you understand? Without all of these components, this thing will not move. Even when you code the chip will only be coded. If you code it, where will you implement the code? It is only when you have the right resources being put together, like a moving car now, like a normal car. Don't worry, we'll get the video. Like a normal car, without the tires, the car will not move. Without the engine, the car cannot move. Even if the engine is being computerized very well, even if it is an engine of a Tesla, it will not move without the tires. It will not move without a gear being put in it, either automatic or manual. So the same way, all of these components are very, very essential to a robot. Now, I believe you all understand how we get to this point. Now, by tomorrow, we'll teach you how to couple it inch by inch and step by step. Now, you can just remove all of these. Remember the first rule: know where you remove them. Know exactly where you remove them. Know exactly where you remove them. You can remove all of this and keep till tomorrow. Don't misplace them. They are very, very vital to this class. So you can remove all of these so that you don't misplace them. Keep them in a very safe place. Here very well. It has a spring on it. It has a spring on it. Please take a very look at it. Do not misplace it. Please keep all of these gears very safe. Keep them very safe till tomorrow when we continue on how to couple it back. Now, I am sure you getting this video, you will know the exact point and how to remove all of these components, detach them from the body. We don't want to jam pack it today that it is still the same day we'll decouple that we also couple it, so that you won't make mistakes, so that you won't get lost in the way, in the middle. Now, we've decoupled it. By tomorrow, we'll couple them back step by step. I hope you understand this class. Don't forget, keep them safe. Keep them very safe. This is the moving motor. This is the controller and bridge controlling motor. And these are the gears. Like I said earlier, this is the chip. We have the male to female wires that pass across the information from the chip being coded to every part of the robot. We have the switch here, and we have the battery cage. We have the power source here. It is being coded so that you look at it here, and it is being transferred information to. We have the speaker here too. We have the speaker here too. That has been programmed that anytime it is being switched on, yes, it makes that sound. So for today, I hope you have learned how to decouple this, and by tomorrow we start all over on how to couple them back. I believe by now, getting this video, by now you would have decoupled your own robot and see exact thing that is inside of it. Thank you very much.